Good morning, class. Mr. Pusky here. Hope you're having a good start to your day. Sorry, this video might be posted a little bit late today. I had some issues with my iPad, but I think I got it figured out. So yeah, hope you guys are excited to get back into learning some stuff, and we're still going to take it easy in terms of not overwhelming you with the amount of stuff that we assign, but it's still important to know that we still learn this stuff for next year, okay? So we're learning chapter 10, which is going to be polynomials and factoring. Okay, so a polynomial. We'll explain polynomials in a second here, but basically we're going to be figuring out like what numbers go into equations or expressions, and so that they'll factor. They'll like when you basically what we were doing like foiling or distributing. We're doing the opposite of distribution, basically. Okay. So factoring is the opposite of distribution, and distribution is like multiplying, and factoring is going to be dividing. All right? So that'll make more sense once we get going in this chapter a little bit, but for now we're going to start with today's lesson. Let's read it as a class. Ready? 1, 2, 3. Adding and subtracting polynomials. Essential question 1, 2, 3. What is a polynomial, and how do we add and subtract polynomials? All right, well, a polynomial is... use red here. One or more terms. One or more what? That was really bad. One or more terms connected by plus or minus signs. By what? And I should have mentioned too that it might be kind of hard to take notes unless you print off these notes. So just do the best you can on another piece of paper. Just write out. I'll try to slow down and give you enough time to write, but you guys can also pause the video if you need more time to write stuff down here, okay? The biggest thing we want to make sure we write down is the actual example problems, all right? So degree is the exponent on the variable, the what? So if we have, for example, 2x to the third, we have negative 7x to the 11th, and we have x to the first. What would the degree be for each of those? What do you guys think? Yeah, what's the exponent for 2x to the third? Hopefully you said 3. What's the exponent on negative 7x to the 11th? It's 11. What's the exponent on x to the first? Okay, so this would be third degree, 11th degree, first degree. Okay? And then degree of a polynomial is going to be the largest exponent, the what? Largest exponent in the whole polynomial. Okay? All right, in standard form, excuse me, got a tickle in my throat, is a polynomial written biggest to smallest exponent. Written what? Written biggest to smallest exponent. And the leading coefficient in standard form, the coefficient of the first term. Of the what? The first term. Okay. So what's the coefficient in these three things up here? What's the coefficient in 2x to the third? Hopefully you said it's 2. The coefficient's the number in front of the variable. Okay? So the number in front of the variable of 2x to the third is going to be 2. The coefficient for this one's going to be negative 7. The coefficient in front of this one's going to be what? There's nothing there. What's it going to be? It's actually going to be 1. Okay? All right, you guys are doing great so far. I also, if taking notes is like, yeah, do your best to take notes, but like also, you know, for your homework and stuff, you'll have access to this video and stuff, which will be a good tool for you. Okay? So to classify by degree, so we have different words associated with different degrees of polynomials. Okay? And you can see, yeah, yep. So remember, polynomials are expressions that are separated by addition and subtraction. You guys see the addition and subtraction symbols here? Okay? These are all polynomials because they're separated by addition and subtraction. Okay? And then, so we have some words we just need to kind of memorize and know. So the 0 degree, which means degree was the exponent. Is there any exponent here for this one or no? Is there any like x to the fourth or anything? There is not. So anything without an x with an exponent, we're going to put constant. It's a what? It's a constant. The first degree, so we have x to the first right here. Do you guys see there's an invisible 1 right there? That's going to be called a linear linear polynomial. Okay, and you guys remember like y equals mx plus b? So if we have just x to the first power, that's going to be a linear polynomial. So the second power is what we kind of talked about before we left school here, was a quadratic. That's a quadratic. And that's because this is a 2. So the third power is called a cubic. A what? A cubic. And then what's the degree down here? Yeah, our leading coefficient has a exponent of 4. This is called quartic. Say quartic. I'll spell it out first. Say quartic. All right, and then after 4th degree, mathematicians just got kind of lazy. So anything like 5 plus or like 14. So basically, this is to the 4th power, 14th power. That's going to be called a 14th degree polynomial. Okay, so anything greater than 5, I guess kind of listed it down here, just named by the degree. Okay, so yeah, so anything 5 and up, you're just going to call it like if it's the 7th power, you call it a 7th degree polynomial. If it's to the 82nd power, it'd be an 82nd degree polynomial. You just put that number right there. Okay. All right, hopefully that makes sense. Let us now move on to classifying by number of terms. I scroll down my notes here. Okay, so terms are however many things are separated by addition and subtraction symbols here. So how many terms do you think 3x to the 5th has right here? Some people could say it looks like it could be like, there's 3 things there. There's a 3 and an x to the 5th. There's just 3x to the 5th. This actually only has 1 term because there's no addition and subtraction around here. So it's just going to be 3x to the 5th is 1 term. That's called a monomial. Say monomial. A monomial. And then what I like to do to figure out how many terms there are, I like to put little walls above and below the addition and subtraction symbols here, okay? So for 4x minus 7, I'm going to put a little wall like above and below the 4x minus 7, okay? How many terms does 4x minus 7 have? How many things are separated by addition and subtraction symbols? Hopefully you said 2, and it is 2 because there's 4x, and then there's negative 7 over here is separated by the subtraction symbol. So this is called, and then when we have 2 terms, it's called a binomial. Say binomial. It's a binomial. Okay. And then the third one, let's go ahead and put some walls above and below the addition subtraction symbols again. Let me draw some lines here so we don't get confused. Being very careful. Okay, so how many terms do we have here for x squared plus 9x minus 11? Well, I see the plus and the minus, so we have x squared, 9x, and 11, so we're going to have 3. We're going to have 3 terms. And that's going to be called, it was monomial, binomial. What do you think 3 terms is going to be called? Hopefully you said trinomial. If you guessed that, way to go, that's pretty awesome. That's a trinomial. And then, so then down here we have the addition subtraction symbol. Okay, how many terms do we have in the bottom there? We have 4x to the square, 4x to the 9th, 6x to the 3rd, 3x, and 8. How many terms do we have there? And we're going to write 4 or more. This is kind of the laziness of mathematicians again. If you have 4 or more terms, you're going to call it a polynomial. And technically, these are all polynomials, but it's just called a polynomial with 4 or more terms, okay? And then down here, I want you to write plus or minus symbols are barriers between terms. Okay? I just realized without all this written down here that it may have taken you a while to write all that down. So, why You guys can go ahead and pause the video if you'd like to get caught up here for a second. So it's easier when we have all the notes printed out in front of us. If you can't print the notes, then it might take you a while to make this table and stuff. So just do the best you can. Otherwise, you can just watch the video and just kind of keep it in the back of your head here, how to do this stuff. So, all right, we're going to do, let's see here. We're going to do... we're going to do one of these examples down here, and then you guys can try the other two on your own, okay? So we're going to do number 3 together, then you guys will try 1 and 2 on your own. So, for number 3, we're at 4z minus 7z to the 6. Okay? So LC stands for leading coefficient. And remember, the leading coefficient is the number in front of the variable with the biggest exponents. Which exponent is bigger, z or z to the 6? Yeah, z to the 6 is bigger. What number is in front of the z to the 6? It is negative 7. So our leading coefficient for this one, even though 4 starts the expression, you can rewrite it as this. You can write negative 7z to 6 plus 4z. That's fine. You can totally do that. And the leading coefficients, no matter where it is in the actual expression, it's going to be in front of the biggest exponent, which is z to the 6. Okay. The degree, was degree the thing separated by addition subtraction, or was it the highest exponent? Yeah, degree was the highest exponent. So what's the highest exponent in, is it z or z to the 6? Yep, and z to the 6 is our highest exponent. And do we have a name for that, or is there a name for a 6th degree, like a linear, quadratic, or no? There should not be. We're actually going to just write 6th degree, like this. And then how many terms do we have here? Well, it looks like we got one subtraction symbol. There's our kind of walls. Looks like we have 4z and negative 7z to the 6. So we have how many terms there? 2. This is called a binomial. Okay? Alright, why don't you guys pause the video and try 1 and 2 on your own, and then we'll go through it together in a second. Alright, welcome back. So for number 1, what's the leading coefficient? There's only one term here. The leading coefficient should be negative 3. What's our degree? What's the highest exponent we see here? It's 9. And then does 9 have a name for it or no? It doesn't. We're going to call it just a 9th degree polynomial. And then how many terms do we have here? Do I go like this, and do I have like something like this, like 0 plus this over here, or no? No, probably not. This is just negative 3y to the 9th. Is this how many terms is that, guys? It should be one term, and one term is called a what? What's the name for one term of a polynomial? Yep, should be called a monomial. Okay, and then number 2. Stuff's kind of out of order over here, but what's the leading coefficient going to be for this one? What's the number in front of the biggest variable, or biggest exponent? Should be 2, because it's in front of the x to the 3rd. And then what's the degree? Looks like the highest exponent is 3, which is called what kind of, what's the name for a 3rd degree? Cubic. Should be a cubic. Then how many terms do we have here? Looks like we have, here's the addition subtraction walls. Looks like we have 1, 2, 3, 4. We have 4 terms, which is called a what? What's the name for 4 terms? Polynomial. So this is a cubic polynomial with 4 terms. Over here is a 6th degree binomial. Over here is a 9th degree monomial. That was how you would describe those polynomials. Okay? All right. Next. Let's scroll down my notes here. All right, so adding and subtracting polynomials. Okay, what we're going to do is we're going to do all subtraction sign changes first. Do all subtraction sign changes first. We are only going to add like terms together. And then like terms are the same variable raised to the same power. How many do we have left here? Got a good amount. All right, so this is like combining like terms on steroids, okay? We have a lot of combining like terms to do here. So, first thing you want to ask, is there anything, are we subtracting anything in we're looking at number 1 here, okay? Is this symbol right here subtraction or addition? It is addition, okay? So we're just going to go ahead, we're going to combine like terms now. We're going to use symbols above the like terms that are alike. That's kind of redundant, but I want to start with the biggest exponent that you see here. What's the biggest exponent that you guys see here? I see negative 7x to the third, I see x. What's the biggest exponent you guys see here? Yeah, x to the third is our biggest exponent. So we're going to put a little symbol, a little dot above there to show that that's the only x to the third. There's no other x to the thirds anywhere over here. So we're going to keep that the way it is right there, okay? All right, after x to the third, what's the next smallest exponent after x to the third? Yep, should be x squared. So we have x squared right there. Any other x squareds? Yep, I'm going to use circles to show these go together. After we did x to the third, x squared, after x squared, what's the next smallest exponent? Yeah, it's going to be x. I'm going to use a triangle. Here's an x, and here's an x. And then we have any other constants or variables by themselves, or numbers by themselves. Yep, we got this 2 and this 4. So now that we labeled them, now we're going to, it says only add like terms together. Now we know what like terms go together because we labeled them. So now we're going to add the like terms. So negative 7x to the third is going to be by itself because there's no other x to the thirds to add. And once I get rid of it, I like to cross it out so it's gone. All right, what's the next smallest exponent? We got negative 9x squared plus, we got negative 9x squared plus 8x squared. What's negative 9 plus 8 going to be? Yeah, it's going to be negative 1 or just negative x squared. You can put a 1 here if you want. I don't like to put a 1. I like to put just negative x squared. So we got negative x squared, negative 9. So we have negative 9 plus 8 equals negative 1. That's where negative x squared came from. Okay, these cancel out. All right, then we have x minus 2x. What is 1 minus 2 going to be? It's going to be negative 1. So we get negative x. These cancel out now. And then what is 2 plus 4 going to be? And we get 6. Okay, so you see what I mean by combining like terms on steroids? We're just adding the like terms. We're adding the numbers in front of the variables, the coefficients. And then we combine them at the end here, okay? And the reason why I start with the biggest exponent first is because we want to write it in standard form, which is with the biggest exponent in front. And now that we did that, the biggest exponent goes 3. Oops. It goes 3. Shoot, I can't get rid of that. 3, 2, 1, 0. That's why we start with the biggest exponent first. Okay. All right, let's do one more example, and you guys will try a couple on your own. Because we have 3, 4, 5 left. Okay, so number 2. So first thing we want to ask in our rules here, is there any subtraction happening in between these polynomials? Do you guys see any subtraction happening right here? I do. I see subtraction. So what I'm going to do is I'm going to change this to addition. And then I'm going to change all the signs of this right-hand polynomial over here, okay? So I'm going to change this is positive 2x to the third becomes negative 2x to the third. This becomes negative 4x squared. This becomes positive 3x. And this becomes negative 1. If you want, you can rewrite it, make it easier to see everything. So we can do that if we want, or else we can just go from there. Plus 5x minus 3 plus negative 2x to the third minus 4x squared plus 3x minus 1. So basically what we were doing there is we were distributing the negative to each of these. And that's going to help us by making them all positive, make it easier to work with. Okay? So So now we can just do what we did before. So what's the biggest exponent you guys see here? I see a x to the third. Anything bigger than x to the third or no? Okay, so we got x to the third is going to be right here. Any other, are there any x squareds? Yep, there's one x squared over here. Any x's? Yep, we got these x's right here. Any constants or numbers by themselves? Yep, we got these guys right here. So this time we do have a couple x to the thirds we can combine. What is negative 6x to the third plus negative 2x to the third? What's negative 6 plus negative 2? It's going to be negative 8x to the third. Those are gone now. Any x squareds? There's just the negative 4x squared. That's going to just come along for the ride because there's nothing else to do with it. Sorry, I keep doing that. Okay. And then any x's? Yeah, we have 5x plus 3x. What's 5 plus 3 going to be? Should be plus 8x. These are gone. And then we have negative 3 minus 1. What's negative 3 minus 1 going to be? Or plus negative 1? It's negative 4. So we should have negative 8x to the third minus 4x squared plus 8x minus 4. Can we combine any like terms here? Any other like terms or no? Yeah, these are not like terms because they do not have any other exponents that are the same. So this is our final answer right here for this problem. Okay. If you feel like you're getting this right now, you can stop this video here. Otherwise, I'll let you guys try. If you want some more practice, go ahead and try these 3 examples, and I'll give you the answers in a little bit here, okay? So here's the 2 examples for you guys to follow your work. Go ahead and try those last 3 examples on your own. On the notes on Classroom, it'll have the work for you to follow along, though, okay? So you guys can stop the video here, or else you can try these last 3 on your own. Go ahead. All right, so the answers for these last 3 should have been, for number 3, should have been 5x squared minus 4x plus 12. Number 4 should have been 9x to the third plus 6x squared minus 4x plus 17. And then number 5 should have been x to the third minus x squared minus 6x plus 2. All right. And there's our notes for today. So, yeah, so that's where we're going to stop for today. The lesson should be posted with the notes should be posted for you on Classroom. And also, you'll be able to find the homework too, which is going to be a worksheet, but you guys will have to do it by hand on your on loose leaf paper. Okay. All right. Thanks for watching. Hope you guys have a good day.